Welcome class. In this video lecture, we're going to discuss the effect of negative feedback in an operational amplifier or op-amp. In our previous video lecture on comparators, ginamit natin ang open loop for the op-amp, which means that the voltage gain is really high that will drive the output to positive or to negative saturation. So ibig sabihin, if we have a supply, perhaps, let's say we have supply of positive 12 volts, and let's say we have negative 12 volts for the supply. Kung meron tayong open loop configuration, yung output natin ay maglalaro sa pagitan nitong 12 at negative 12 na to. So kung positive saturation siya, it's the output voltage will be approximately around 11 volts. So yung 1 volt na yun, probably napunta dun sa ating device. And if it is driven into negative saturation, the output will be approximately equal to, let's say, negative 11 volts. So that's actually a safe approximation of the positive and the negative saturation points ng ating output if an op-amp is in open loop. So what if we incorporated or connected a feedback element from the output papunta sa inverting input ng ating op-amp, or yung tinatawag na minus input? In this case, in our diagram, the output is fed back via a negative feedback circuit pabalik dun sa ating inverting input ng ating op-amp. So you have an input signal here, which is a sine wave, okay? And there's a corresponding amplified output, and that output is being fed to your inverting input. So an internal inversion takes place dun sa ating op-amp, no? 180 degree out of phase with V in. Okay, and while the output is being fed back to your inverting input, it is being attenuated by an attenuation factor or attenuation constant, which is based on your feedback element. So we can connect a voltage divider on the output, and we can know, or we can control the actual attenuation that can will have an effect on your output papunta doon sa ating inverting input. So that's basically your negative feedback. So returning a portion of the output signal to the input with a phase angle that opposes the input signal. So we know kapag opposite ang phase ng ating signals, nagkakaroon tayo ng subtraction, no? Nagkakaroon tayo ng difference between the two voltages or signals that are present at the input of your operational amplifier. Ito yung advantage ng negative feedback in an op-amp, no? Nakokontrol natin actually yung gain or voltage gain ng isang op-amp by incorporating a negative feedback. Unlike sa open loop, hindi natin makokontrol yun. That's why nagsasaturate pataas or nagsasaturate pababa yung ating output, giving us the output of a clipped output, or somewhat of a square wave, no? Kung meron tayong periodic na input, no? Nakiklip yung ating signal, so nagiging square wave siya. But for the negative feedback, nakokontrol natin yung value ng gain. That's why hindi siya umaabot doon sa ating saturation point sa positive at sa negative, no? In addition also, nakalagay dito, no, bandwidth and the input and output impedances can also be controlled. So kung meron tayong circuit na mataas yung impedance at meron tayong load na mababa yung impedance, we can control that para magkaroon ng matching with the impedances between different stages in a network or circuit. So this is a non-inverting amplifier. It utilizes negative feedback. So parang doon sa nakalagay kanina. So nakalagay kanina, block diagram lang. No, but this time, yung feedback element natin will be a voltage divider from the output pabalik dun sa ating inverting input. So as you can see here, the voltage divider is composed of two resistances. We have RF, or the feedback resistor. So let me just encircle that. RF, or the feedback resistor, and RI, or R sub I, which is the input resistor. So kung anong voltage ang lumalabas doon sa ating R sub I na resistor, siya ring nagiging input natin doon sa ating inverting input of the op-amp. So we call that V sub F, or the feedback voltage. And also, ina-apply natin yung ating input signal, this one, sa ating non-inverting input. Okay? So that is a basic non-inverting amplifier. So in this case, we can control the amount of voltage gain na magkakaroon dun sa ating circuit. Unlike dun sa open loop, as I've said before, no, hindi natin siya makokontrol. Alright, so we have this gain, the closed loop. So CL here, ACL, of the non-inverting amplifier is equal to 1 plus RF over RI. But let us derive that. Paano ba tayo nagkaroon ng ganyang closed loop voltage gain for the non-inverting amplifier? Let us now derive the equation for the closed loop voltage gain of the non-inverting op-amp. So let me just redraw this part, itong ating feedback circuit. So let's say this is our output. Let's say that's a sine wave. So this is V out. Alright, and then we have RF, and then we have RI. So we're concerned with the voltage across RI because that's the voltage at your inverting input. So that's V sub F. So this is your V sub F. So we can now write the voltage divider equation. So the total voltage is V out. Total resistance is RF plus RI. And then we need to get the voltage across RI, which is V sub F, which is the feedback voltage, divided by the resistance RI. So we can now write down the equation for V sub F. So V sub F is equal to R sub I over R sub F plus R sub I times V out. So we know here that the output is divided between RF and RI. So for example, we have 1K for RF, and then let's say 1K also for RI. So the output is then divided by 2. So for example, if your V out is, let's say, perhaps 5 volts RMS. Alright. So ang magiging input mo dun sa ating inverting input would be a half of that. Kasi ito yung ating attenuation. No? So we can write that as B. This is the attenuation constant or attenuation factor, or just simply the attenuation. That is equal to R sub I over R sub F plus R sub I. So yung ating output ay nadi-decrease, no? Bumababa siya, depende doon sa attenuation natin. And it is being fed into the inverting input of our op-amp. So that would be our attenuation. We know that in an op-amp, the differential or the difference voltage between the inverting and the non-inverting input is taken, and then it is being multiplied by the voltage gain. So kinukuha muna natin yung difference between the inverting and the non-inverting input. So we have here, di ba ang input natin ay, we have Vin, which is this one, and Vf. So we can write down the differential voltage as V sub D equals Vin. And since ang VF natin ay naka-feed into the inverting input, meron tayong minus VF. So that is our differential voltage. So that differential voltage, yan yung ina-amplify natin. No? So ima-minus mo muna yung dalawang input mo and then multiply it by the gain, by the voltage gain, in order for you to get the output. So we can write now the equation for the output voltage. So based on the difference in the inputs, so that's A times the open times Vin minus Vf. So kanina yung Vf natin or yung feedback voltage natin, V sub F, is equal to R sub I over R sub F plus R sub I times V out. And then alam natin na ang attenuation natin can be represented by the capital letter B, that is R sub I, divided by R sub F plus R sub I. Alright, so Vf can now be written as B or the attenuation times V out. Ngayon, pwede nating palitan yung Vf dun sa ating output voltage equation. No? Alright, so we have V out is equal to open loop voltage gain times Vin minus B or the attenuation times V out. Alright? So, ang concern natin dito ay makuha yung or ma-separate yung V out tsaka yung Vin para makuha natin yung V out over Vin natin. Alright? So, we have V out is equal to open loop voltage gain times Vin minus open loop voltage gain times the attenuation times V out. So, dinistribute ko lang itong ating open loop voltage gain dun sa ating Vin minus B times V out. And then, we can separate lahat ng merong V out on the left side of the equation. So, we have V out plus AOL times the attenuation times V out equals AOL times V in. So we can factor out V out. So that is 1 plus AOL times the attenuation B equals AOL times V in. So we have V out. Of course, divide natin yan sa V in. So ito yung V out natin and this is our V in. So that is equal to the open loop voltage gain divided by 1 plus open loop voltage gain times the attenuation. So, alam natin na open loop voltage gain, sobrang taas yan. So, probably nasa 100,000 mahigit yan sa isang operational amplifier. So, depende kung anong type or model ng operational amplifier yung gagamitin natin. But, it is much greater than 1. So, we can approximate this one. So, this is AOL times the attenuation is much greater than 1. That's why yung ating denominator ay magiging AOL times attenuation B na lang. So we can cancel out, probably itong gamitin natin yan. Cancel out AOL, so that would be 1 over B. So we can write down the equation for the output voltage divided by the input voltage. That is actually your closed loop voltage gain ng isang non-inverting amplifier. So that is equal to 1 divided by the attenuation B. We know that the attenuation B is equal to R sub I over RF plus R sub I. Okay. Multiplied by the reciprocal of the denominator. So we have 1 times RF plus RI over RI. So this is equal to RF over RI plus RI over RI. So we can divide RI by RI. So we have now RF over RI plus 1. And that is your closed loop voltage gain for the non-inverting operational amplifier. So that is why meron tayong ganitong equation for the voltage gain of the non-inverting amplifier. So let's have an example for the non-inverting amplifier. So we have here an RF of 82 kilo ohms, an RI of 3.3 kilo ohms, and then the input voltage is applied to your non-inverting input. That's why it's called a non-inverting amplifier. No? Kasi nga yung input natin ay nakarekta sa non-inverting input or plus input. Kapag ang input natin ay in-apply natin dito sa ating inverting input, ang tawag na doon ay inverting amplifier. Alright. So in our example, we are tasked to determine the gain of the non-inverting amplifier. So, alam natin equation ng closed loop voltage gain ng non-inverting amplifier as 1 plus RF over RI. So we just substitute the values. So it's that easy. So the closed loop voltage gain of the non-inverting amplifier is equal to 1 plus RF over RI. So substitute the values for RF, which is 82 kilo ohms, and RI of 3.3 kilo ohms. We have 25.8. So the gain is unitless. So any voltage gain is unitless kasi that's makakancel yung ating kilo ohm na unit dito. So for example, we have an input of, let's say, this is equal to 10 millivolts. All right. So what would be the corresponding output? So it's very easy, no? Kasi we have, alam natin na ang equation of the gain, the voltage gain is V out over V in. So that is the closed loop voltage gain. All right. So we just substitute the value for the closed loop voltage gain, which is 25.8 unitless, and then V in is 10 millivolts. So this is equal to 258 millivolts. So ang nagpasok tayo ng 10 millivolts sa ating non-inverting input, and then it is being amplified by the operational amplifier, at ang output natin ay naging 258 millivolts. We now go to an inverting amplifier. So this is another configuration of the op-amp, wherein yung ating input, which is Vin, is applied to our inverting input or minus input. But still, we have a feedback element. So we have RF and RI pa rin. So kanina, dun sa ating non-inverting amplifier, dito natin nilagay yung input. So take note of that, no? So it's an inverting amplifier because ina-apply natin sa inverting input yung ating input voltage or input signal. All right? And this one, so this non-inverting input is directly connected to the ground. Okay, so that's the difference between the inverting and the non-inverting amplifier configuration for the op-amp. Since it has feedback elements such as RF and RI, we can still control the amount of voltage gain of the amplifier, unlike sa open loop. So yun nga talaga ang advantage ng closed loop, no, over the open loop, and yung difference between the outputs. Yung output ng ating open loop nagsasaturate, yung output ng ating closed loop we can control. Alright? For the inverting amplifier, yung feedback natin, ito, fino-force yung ating input, the inputs to be nearly identical. So mamaya malalaman natin no, paano sila magiging identical. So the inverting input is very close to 0 volts. Okay, so very close to 0 volts to. So mamaya malalaman natin yan habang dinederive natin yung equation for the closed loop voltage gain ng inverting amplifier, which is equal to negative RF over RI. So kung papansin natin, yung equation for the closed loop voltage gain ng non-inverting amplifier is positive, wherein sa inverting amplifier, it's negative. So it doesn't mean na nag-decrease siya. It just means na meron tayong 180-degree phase shift doon sa ating output. So dito natin, itong concept na to is very important, the concept of virtual ground. So at your inverting input, this one, we have a 0 volt potential. That's why it's called the virtual ground. All right. So let us now proceed with the derivation of the closed loop voltage gain ng ating inverting amplifier. Let us now derive the equation for the closed loop voltage gain of an inverting amplifier. But before that, we should write down some of the parameters of our circuit. So at this point, we know that this is our virtual ground. So it means that it is at 0 volt potential. And the difference between the inverting and non-inverting inputs is 0 volt. So parang nakakonect yung ating inverting input dun sa ating non-inverting input. That's why it is called a virtual ground. So we also write the different currents that pass through our feedback resistor and the input resistor and the corresponding voltage. So let me just copy and paste this one. All right. So we have here Vin. Na-apply natin dito sa part na to. So we have an input current that goes into this node. So we write that as I sub I. And then there will be an induced voltage on your Ri. We have plus and minus, right? And then we know that the ideal input impedance of an operational amplifier is very high. So mataas na mataas yung input impedance natin. If the input impedance is very high, of course, yung kuryente papasok sa kanya ay sobrang baba na lang. So let's call this I1. So that is equal to 0 milliampere. So ulitin ko lang, no, yung kuryenteng pumapasok mismo dito sa inverting input natin can be approximated as 0 milliampere dahil sa sobrang taas ng input impedance natin from ohms to, diba? So that's the relationship between the current and the impedance or resistance, diba? So the current is equal to V over R. So pag mataas yung impedance or yung resistance natin, yung kuryente natin ay mababa. Alright. And then next, since itong kuryente natin I sub I ay pumupunta dito sa node na to, it will be divided into two. So one is I1 and another one is IF. So we will call that IF. And then the induced voltage across RF is plus minus, ito yung kanyang polarity. And then we have V out. So because I1 is equal to 0 milliampere, that's the reason why I sub I, or the input current, is equal to I sub F, or the feedback current. And we can write down the equation for I in, or the input current, I sub I. We have I sub I is equal to V sub I over R sub I. Bakit? Kasi itong part na to, we can withdraw that. This is your V in, and then this is your Ri. Remember, yung common na terminal ng RI natin is applied to your inverting input, which is your virtual ground. So parang nakakonect siya sa ground natin. Okay? That's why, yung dumadaloy na kuryente dito, which is I sub I, no? So pwede natin gamitin dito sa equation na ito. So we have the equation for I in. How about IF? So ito naman, itong part na to, yan. So let me redraw that part. So we have RF, and then this is your V out. So nire-redraw ko lang yung input and feedback paths natin, no? And then yung left side ng ating RF is connected to your virtual ground. That's why parang meron tayong ground dun sa kaliwa ng ating RF. So we have plus and minus, and this is your IF. Okay. So let us write down the equation for V out. Ang V out naman natin is equal to, from Ohm's law pa rin, no? So we have IF times RF. But since yung kuryente natin ay palabas dito at papasok dun sa ating V out, no? Meron tayong negative dito. Alright? And then we can write down the relationship between I sub I or I in and I sub F. Okay, so probably lagyan natin dito, liitan natin onte. Okay. So, i-write natin equation natin. So, we have the input current is equal to IF dahil mataas ang input impedance ng ating op-amp. That's why yung I1 is approximately equal to 0. Kaya equal itong dalawang ito. Okay, and then we have the equation for II, which is V sub I over R sub I. So ito yun. Okay, and then the equation for IF. So i-derive lang natin from this equation. So we have IF is equal to negative V out over RF. So i-replace lang natin dito sa right side yung term na IF natin. So this is equal to negative V out over RF. Alright? So ang concern natin is to get the closed loop voltage gain, which is the output over input. So laging ganun, no? Yung voltage gain natin is output voltage divided by the input voltage. So ang output voltage natin is the voltage of the signal at your output, and the voltage at the input is the voltage of the applied signal at your input. So depende kung ito ay inverting or non-inverting configuration. So V out over V in is equal to, so i-rearrange lang natin itong equation na to para makuha natin yung closed loop voltage gain ng inverting amplifier. So that is equal to negative RF over RI. So again, this is unitless kasi ang unit ng resistance is in ohms. So unit ng RF is in ohms, unit ng RI is in ohms, so magka-cancel siya. So meron tayo ngayong gain na negative RF over RI. So that's the reason bakit meron tayong equation for the closed loop voltage gain of the inverting amplifier na negative RF over RI. So let us have an example for that. No? So determine the gain of the inverting amplifier as shown. So titingnan muna natin if it is really an inverting amplifier. No? So kapag inverting amplifier, dapat yung input natin ay naka-apply sa inverting input or minus input. And the non-inverting input or the plus input is directly connected to the ground. So tama naman yung ating circuit. So this is an inverting amplifier. We have RF and RI to control the gain. So that is called the feedback resistor and the input resistor. So ang gain natin, di ba ang equation natin for the closed loop voltage gain of the inverting amplifier is ACLI equals negative RF over RI. So isa-substitute lang natin the values. No, we have 82 kilo ohms divided by 3.3 kilo ohms and then times negative. So that's negative 24.8. And then yung minus sign doon, it indicates inversion or phase shift. So kung meron tayong input na, let's say, 10 millivolts for the positive half cycle na lang. So let's say ito, the peak is, let's say, 10 millivolts. The corresponding output is 248 millivolts, pero baliktad. So let's say this is negative 248 millivolts. So this is your input, and this is your output. So it's being amplified, but it's being phase inverted. This is the comparison between an op-amp that is without negative feedback and with negative feedback. So the first one is in terms of voltage gain. No? So without negative feedback, the open loop voltage gain is very, very high for linear amplifier application. So meaning, hindi natin pwedeng gamitin bilang linear amplifier yung ating op-amp kung ito ay open loop. Pero pwede natin silang gamitin bilang mga comparators. Kasi sa comparators, we're just determining if the input signal is higher or lower than a reference voltage. So kung mas mataas ang ating input than the reference voltage, probably it will go into positive saturation. Kung mas mababa naman, it will go into negative saturation. And vice versa naman kung baliktad yung ating reference voltage and yung ating input voltage. So please just refer to my video lecture on comparators for a detailed discussion on that one. In terms of input impedance naman, this is without negative feedback, it is relatively high. So mataas ang ating input impedance. For the output impedance, it is relatively low. All right. For the bandwidth, it is relatively narrow because of the very high gain. So there's just a small set of frequencies that can pass through your op-amp if it is not using negative feedback. But with negative feedback, in terms of the voltage gain, so it's called the closed loop voltage gain, pwede natin kontrolin. So pwede natin iset to a desired value depende sa design parameters natin. Depende sa pangangailangan ng ating circuit or ng ating design. So it is controlled by RF and RI. All right. In terms of the input impedance, it can be increased or reduced to a desired value depending on the type of the circuit. So on our next video lecture, i-discuss natin yan, no, yung input or the impedances present in your operational amplifier. For the output impedance, it can be reduced to a desired value also, no? And then the bandwidth is significantly wider compared sa ating op-amp without negative feedback. Kasi nga, yung gain natin dito mas maliit compared dun sa ating amplifier without negative feedback. We have a special case of an inverting amplifier. So this is called a voltage follower, wherein yung ating output is directly connected to the inverting input of our operational amplifier. So it means that the gain will be equal to 1. So the voltage gain is equal to 1. So since the closed loop voltage gain of a non-inverting amplifier is equal to 1 over D, or the attenuation, so it's equal to 1 over 1. Kasi nga yung attenuation natin, no, is equal to 1. That's why the voltage gain of a voltage follower is equal to 1. So ito, ginagamit natin to if we have a circuit that has a very high output impedance at gusto natin i-match sa isang load na merong mababang impedance. So it's actually what we call a buffer or a voltage buffer. No? So kung meron tayong high impedance na circuit and meron tayong low impedance na load, kailangan natin ng circuit sa pagitan nila. So it will act as a buffer in between the circuit and the load. Right? So bakit siya tinawag na voltage follower? Kasi kung ano yung pinasok natin dito, sa ating non-inverting input, siya rin yung lalabas dito sa ating output. So kung nagpasok tayo, for example, ng ganito, so let's say this is 1 volt, no? Lalabas siya dito, the same thing then, almost the same thing. So 1 volt. Probably meron lang konting difference due to losses, but they're practically the same. So, ito naman, no, it avoids loading effect, no? Kasi nga na-isolate natin yung high impedance uh, na output ng isang circuit and yung low impedance na load. So thank you for listening. That would be all for our video lecture on non-inverting, inverting, and voltage followers. So that's the effect of negative feedback. For the next video lecture, we will determine the different impedances in our operational amplifier.